Hey everyone, so this is part 2 of our two-part lesson. In this lesson, we are going to be talking about finding unknown angles when you are solving a right angle triangle and using your trigonometric ratios. Before you watch this video, it's really important that you watch the quick video on how to find the inverse function on your calculator because we are going to be using it. Okay, so make sure you are familiar with that. Let's get started. What are our steps to finding our unknown angle? They are very similar to the steps to find an unknown side. First things first, we're going to label our triangle with opposite, adjacent, and hypotenuse. We are then going to select our ratio and set up our equation and use our inverse function to solve. So let's get started here. Find the measure of the unknown angle. In our first triangle, I have two sides given to me, 55 and 34. X is my unknown angle. I start by labeling my sides. The side across from my right angle is my hypotenuse. The side across from my angle of interest is my opposite. And my last side is my adjacent side. I need to pick a ratio that includes both opposite and hypotenuse. And let me just write out my SOHCAHTOA here. Okay, so in this case, I'm going to be picking sine because sine involves opposite and hypotenuse. I'm going to set up my equation. Sine of theta is O over H. And in this case, we don't know what theta is, but it's called X. So I'm just going to replace theta with X. Sine of X is 34 divided by 55. Now, in order to isolate X, sine is a function that's being applied onto X. So just like when you are used to isolating X, you need to be doing the opposite in order to remove the sign. You need to be doing the opposite operation. The opposite operation is that inverse function I was talking about on your calculator, okay? In order to do that, what we're going to do is we're going to write sine inverse of sine X is sine inverse of 34 over 55. Sine inverse is the opposite of sine, leaving me with just X. X is equal to sine inverse of 34 over 55. And how do we write sine inverse? Well, the inverse of any of these functions of sine, cosine, and tan, the inverse is written with this little exponent of -1. It does not actually mean it is to the power of -1. That is incorrect. What it just means when you're dealing with sine, cosine, and tan is that it is the inverse function, okay? We are not putting sine to the power of -1. Do not get that idea in your head. In order to do this on my calculator, I need to use the second feature button and press sine. That'll give me the sine inverse. And then I can type in 34 divided by 55. That's going to give me this nice long number. We're just going to round to the nearest whole number. That's usually what you do when you are dealing with angles. So 35 or 38 degrees is about X. So X is about 38 degrees. Okay. Again, the inverse function is used to undo the trig function that's being applied to your angle, and that's how we isolate our angle and we can find it at the end of the day. Okay, you do not need to write out this step. You can just skip to this line here. X is sine -1, 34 over 55. But I wanted to show you what was happening and that we are indeed canceling it out here. Let's do our second example here. I have been provided with a right angle triangle again where I have an X, a 56, and a 52. Let's go ahead and label our sides. 56 is my hypotenuse because it is across from my right angle. The blank side here is O because it is opposite from X. And 52 is my adjacent side because it's the one that's left over. I now need to pick a ratio that has H and it has A, and that's going to be cosine. Cosine is adjacent divided by hypotenuse. So cosine of theta is adjacent divided by hypotenuse. Theta again has been written as X, so I'm going to replace that with X. Adjacent is 52, hypotenuse is 56. Now, in order to isolate x, I need to take the cosine inverse. I'm going to do cosine inverse of 52 over 56. And I can type that directly into my calculator. Second feature cosine gives me the cosine inverse. 52 divided by 56. Okay, and I am left with, we're going to round up to about 22 degrees. So x is about 22 degrees. So pretty straightforward. Again, setting up your equation, taking the inverse, and solving. Let's do a word problem. A wheelchair ramp can have a maximum slope upwards of 4.8 degrees. A customer has asked you to build a ramp to overcome the 3 centimeter lip of their curb. The ramp will attach to the sidewalk 38 centimeters away. Is a ramp within code possible? Let's start by drawing a diagram here. So we have a curb that needs to be overcome. That curb is 3 centimeters long. We need it to attach to the sidewalk. The sidewalk is going to be over here. And the sidewalk is 38 centimeters away. We know that code states that the angle up here has to be 48 degrees or less. So we need to figure out what this angle is in order to be able to compare it to the 4.8 degrees. Okay, we need to consider that. So let's set up our ratio here. We've drawn our diagram. This is my right angle. We have our curb of 3 centimeters as well as our distance to the sidewalk of 38 centimeters. I'm going to start by labeling my triangle. The dotted line here is my hypotenuse, 3 centimeters is my opposite side, and 38 centimeters is my adjacent side. I need to pick a ratio that involves opposite and it involves the adjacent. And that in this case is going to be tan of theta is opposite over adjacent. Theta in this case is x once again, so I'm going to replace theta with x. Opposite is 3, adjacent is 38. And in order to find x, I need to take the tan inverse of that fraction. Okay, I can type that straight into my calculator. Tan inverse of 3 divided by 38 gives you about 4.5 degrees. 4.5 degrees is less than 4.8 degrees. So we know that a ramp is possible because we are under code. We are less steep than the 4.8 degrees. Because this is a word problem, I'm going to finish with a therefore statement. Therefore, yes, a ramp within code is possible. The angle upwards is only 4.5 degrees. Okay, and there you have it. So once again, we started by drawing a diagram, we picked our ratio, we wrote our equation, and then we used the inverse function to solve. Great work, everybody.